So this point slope formula line is a much more efficient way to write the equation of line. Okay? And it's nice because although we still have to calculate slope, it can use any coordinate on the line. Any x and y pair can be plugged into this equation. And we don't need to worry about solving for the y-intercept anymore. But why does this work? Well, really it's just based on the slope formula. Okay, so if I have any line, I've got a point, x1, y1. So that's some known point on the line. And I can just find a general point here, and we can just say that that's x and y. And we can move that x and y anywhere we want. Okay, so that point is this point expresses every coordinate on this line. But no matter where I put that x, y, the slope is going to be the same. And I can calculate the slope using, I'm going to do it a little bit backwards, but I'm going to do y minus y1 is my change in y. And I have my change in x is going to be x minus x1. And so I can say then that my slope is equal to y minus y1 divided by x minus x1, which is true. Now the point slope formula, because this x and y is a general point and expresses every single coordinate on this line, all I have to do is rearrange this expression into this. So I'm just going to multiply both sides by the denominator. So I end up with x minus x1. That's equal to y minus y1, and there's my point slope form. It's just really just a rearrangement of the slope formula, and that's why it works. And it works because this x and this y is this one right here in red, and this is the one, this point can be moved anywhere on that line, so that anywhere, no matter where I put it on that line, it's still going to calculate a slope using the fixed point x1, y1. So let's do another example of this to see how we do this. So the basic steps are find the slope, plug in a coordinate. And it doesn't matter which x1 and y1 I use. Okay, it doesn't matter. I can just plug in either one, and then I'm done. I'm finished. Okay, so my slope then, well, first of all, let's graph this. -1, +1. Okay, let's change the scale here. So -1, +1. We'll scale the x-axis. So then y equals 2, 4, 6. Sorry, x equals 2, 4, 6, 8, 10, 12, 14, and then 5 up. Right there. So we'll scale the x, and then there's my equation of my line. I'm not concerned about the y-intercept, so I'm not going to bother putting it into the y-intercept form. I'm just going to find my rise. Okay, 5 minus -1 is going to be +6. My run is going to be 14 minus -1, so it's going to be +15. So my slope, when I calculate my slope, is equal to +6 over +15. That's going to simplify to 2 over 5. I'm going to then plug in my equation, and I'm just going to move that y1 to the other side. So I'm going to have my slope 2 over 5. Now if you want to keep the y1 over that side, that's fine. I'm going to do x minus x1 plus y1. And what I need then to finish this off is I just need to plug in one of these two coordinates, either these ones or these ones. I'm going to put that one in just for no reason other than I randomly selected that. Okay, so I'm going to put my x and y's in the right spot, and I'm done. If you really want to calculate the y-intercept, you can go ahead and expand these brackets and combine the like terms, and that will find the y-intercept. But the point slope form does not rely on having to find the y-intercept. The coordinate that defines the location is just going to be one of the two coordinates that was given. So here we've been given the intercepts. The x-intercept is 2. The y-intercept is -3. I've got my line that goes through like this. I've got a nice convenient triangle I can use here. Okay, so it goes 3 and 2, so it goes up 3 over 2. So my slope is equal to 3 over 2. Plug it into my formula. Y equals my slope. And then it's going to be minus x plus y. Why don't we use the y-intercept? Okay, we'll use the y-intercept as our x and y coordinates. So x is 0, y is -3, and I'm done. There's my point slope form. Okay, now obviously this one we really can just easily simplify this. This will just end up being y equals 3 over 2x minus 3. And there's my y-intercept showing up in my mx plus b form. But as a linear equation, if we don't need the y-intercept, this is good enough.